So what's this a picture of? I saw you say it. What'd you say? Mars. So did you guys know that Mars doesn't really have a magnetic north or south? Because of that, Mars doesn't have much of an atmosphere. Mars has a very thin atmosphere. But we're finding more and more that Mars actually used to have an ocean. Still has a little bit of ice on the poles where it's cold, but it actually used to have a lot more. We know that because it has a lot of sedimentary rocks, sedimentary features. So I got a demo today that actually shows you guys how the Earth's magnetosphere works. So this is kind of one of my favorite demos. The first thing we have to talk about is how you can form a dynamo. So this is a schematic cross-section of this dynamo that I actually have here today. So when I spin the rotor, I want you guys to also see that rotor there. And so really all a dynamo is metals moving past each other, right? But it actually generates a magnetic field. So check this out. So this is a magnet that's out of a hard drive of a computer. So it's a neodymium and metal, but it's extremely magnetic. Is this plexiglass at all magnetic? Can it actually do anything with electricity? Can it conduct electricity? So what do you think is going to happen when I drop this magnet down the plexiglass? It's going to go pretty fast, isn't it? It's going to go basically the speed of gravity. You ready? Can I get a countdown? Why are you plugging your ears? We don't have any explosions today, I promise. All right, you guys ready? Countdown from 3, 2, 1. Was that sweet or what? Now, I have a sheet of aluminum. Is aluminum magnetic? It's not, is it? Can it conduct electricity though? Yes, in fact, if you go to Home Depot or a hardware store, you have the choice of buying aluminum wire or copper wire. Check this out. Now, if I blow your mind, I want to hear some oohs and ahs. You ready for this? So you've seen that it does not stick to the aluminum, right? Watch this though. When I let this magnet fall, watch how fast it falls. Oh, come on, you guys can do better than that. I want more oohs and ahs. You guys ready for this? Here we go. That's better. So this shows us that something that's electrically conductive, like this aluminum, can actually generate a magnetic field. So you guys want to actually check this out on your own? All right, so I'm going to pass. I got 3 of these. That's what's called the lens effect. I'm not going to test you on it, but you first have to understand that before we can actually talk about how you make a magnetic north and south pole just with motion. So believe it or not, the Earth, when we look into this section of the Earth has a core, doesn't it? So right here, can everybody see that? So this is a cross section of the Earth, and you can actually see that it has a core. The core is made out of iron and nickel, isn't it? Is it solid? Is our Earth core solid? It's not solid. In fact, the outer layer of the Earth's core is liquid. So that liquid is actually kind of moving its own speed in the core of the Earth. And it's that motion of a liquid metal with the solid center core, and all that interacts to actually make a north and south pole. So you want to see what happens when we do this with a dynamo? So because we don't have the size of the Earth, this isn't very efficient. So what I've had to do is kind of cheat it a little bit and put a coil of wire here. This is a Brunton compass. So if you guys ever go farther in geology, you might actually own one of these. But check this out. So everybody can see that? So right now that Brunton is pointing to the north, right? Up to the Catalina Mountains. And so I'm going to spin the rotor of this dynamo. You guys ready? Look at that. So you can see me down there spinning this dynamo. And so this dynamo is actually what's happening in the core of the Earth. Because we have a liquid outer core and a solid inner core, it's basically doing this spinning. And that generates the magnetism. And now you might be wondering, big deal, why do we care? Check this out. And so we have formed this magnetosphere. And if you want to learn a lot more about this and see amazing computer graphics, check out this YouTube link. It'll take you much further than we have time for in this class. But that magnetosphere actually protects us from the solar wind. Without a magnetosphere, without a magnetic north and south, that solar wind would actually strip the Earth of all of our waters and gases in the atmosphere. And so we would look a lot like Mars. And you might be thinking, that's not a bad thing, right? Would you guys like to live on a planet like Mars here? Or would you rather live on a watery planet like the Earth? I'd like to live on the Earth. And so that's all because we have that liquid core in our planet. And so the cool thing is that we have this magnetosphere basically around the, protecting the planet Earth this way, but we also have these poles. It's like a big donut, isn't it? So the poles are where a lot of this solar energy can actually enter the Earth. And so that's why we get these auroras. And so we get the aurora borealis in the north, we get the aurora australis in the south. And so these are charged particles from that sun energy that basically form plasma, and they rain down at the poles because that magnetosphere is weak at the north and south pole. But it still protects us. So that is the reason why we're still here today. Just because we can generate a magnetic north and south pole, which protects us and holds all of our volatiles in, our waters, our gases, and everything. Any questions on that?